Okay, this video is for completing the square when a does not equal 1. So we're going to use this equation, 3x squared plus 12x plus 15 equals 0, and we're going to divide the entire equation by this a value of 3. That's going to yield x squared plus 4x plus 5 equals 0. And now we go back, we see now we have a is 1, so now we're just going to go ahead and complete the square just like we did in the last video. So we know that we would like our c value to equal b divided by 2 squared. And so b is 4. So we would like this to be 4 over 2 squared. So that's 2 squared, and that's going to be 4. We'd like this number to be 4. So in the last video, what we did was we moved the 5 over, we moved our c value, the given value, over to the other side of the equation, and then we added our new value. In this case, what we're going to do is, just because these numbers are a little simpler to work with, if I want this to be 4, I could just subtract 1 from both sides of this equation. So when I do that, I get x squared plus 4x plus 4 equals negative 1. Okay, now I've got my perfect square trinomial. I know that this should be, x plus b over 2, so that 4 over 2, that's 2 squared. And that, you can check it and make sure it works. X plus 2 squared. That's going to get x squared, 2x, and 2x. That's my 4x. And then 2 times 2 is 4. Okay, great. So we're going to have x plus 2 squared equals negative 1. Now we're going to take the square root of both sides. Notice this is a negative and there's no real solution here. So we're going to end up with some complex solutions. So when we take the square root of both sides, we're going to get x plus 2 equals plus or minus the square root of negative 1, which is simply I. Okay, so we'll subtract 2 from both sides. Oops, hold on. We got to have a plus or minus in here. And so we're going to have x isolated. It's going to be negative 2 plus or minus I. And so that's our solution. That's the answer when this equals 0. So when you think about this, the graph here, it means it doesn't touch the x-axis, right? There are no real solutions here, which means there are no x-intercepts. And that makes sense. So just exploring this a little bit more, if you were to find the vertex of this, you would find that because a is positive, we know that this parabola opens up. The vertex must be above the x-axis. So let's find out where that is. And so the vertex, remember, from standard form is going to be the opposite of b over 2a. That's going to be our h value. And so we're going to have negative 12 over 2 times 3, which is negative 12 over 6, which is negative 2. So h is going to be at negative 2 for x. Our k value is simply going to be the function when you plug in h, or in this case, negative 2. So we'll let x equal negative 2. And solve. And we get 3 times 4. Let's do minus 24 plus 15. Well, that's 12 minus 24. That's negative 12 plus 15. Carry that through, and we get 3. So k equals 3. And so our vertex is going to be at negative 2 and 3. And it's going to open up, and our a value is 3. So when we move 1 unit in the x direction, we should see that we're going up 3 in the y direction. Okay, so it's a narrow parabola. I want to review this with you because our next step in completing the square is what I want you to notice from this step here And when we create our perfect square trinomial and set it equal to -1, we're setting ourselves up for using completing the square to also convert to vertex form. So when we want to convert to vertex form, we can do it using completing the square. However, we could also just solve for h and k like we did here. So for the vertex, we know that h was a -2, k was 3. We know what a is from our original equation. So we could write vertex form without completing the square. We would just have f of x equals 3 times x minus h. H was -2, so that will show up as a +2, and then plus k. So we can convert to vertex form without completing the square, but we often teach completing the square in order to convert to vertex form. However, we need to preserve a, and so that's going to be our next video. How do we do it without dividing a away? So when a doesn't equal 1, if we want to solve, we can divide a away. However, if we're trying to convert, we can't divide it away. So that will be our next video.